That sounds fascinating. I have 100 questions that I want to ask about all of that, but we have reached a point in the show where I just need to take a very quick break here, Tom, in our discussion, because I want to make sure that I tell our listeners a little bit more about IFPE, the International Fluid Power Exposition. IFPE is the place where you're going to be able to learn everything that you need to help your company stay at the forefront of the mega trends affecting your business and industry. From sensor technology and data analytics to robotics and automation, you're going to see the latest innovations in fluid power that are going to help your machines and your applications achieve your technology, performance, and business goals. Only at this show, at IFPE, can you have in-depth technical conversations with engineers and other executives to help you spark new ideas. You can talk to suppliers about your specific challenges and the solutions that they offer. Or you can find new suppliers and find new ways of getting things done. Or you can attend innovative education classes and sessions that will cover the latest fluid power topics and industry trends, including college-level courses that can provide professional development hours. There is no other trade show that brings as many sectors of the fluid power, power transmission, and motion control industries together in one place. And this wonderful event only happens once every 3 years in conjunction with ConExpo ConAg, the largest international gathering for the construction industries. Our next IFPE trade show is going to be March 14 through 18, 2023 in Las Vegas, Nevada. To learn more or to reserve your place, visit IFPE.com. Okay, Tom, let's get back to what you were just describing, and that is the data collection and data analytic user interface, if I can call it that that is part of this. I'm curious, so like how much the uniqueness of the design, the drive part of it, how much of that is needed in order to have that kind of data analytic approach to, are those two things, they go together, or you could have them separately, I guess is what I'm asking.
Well, it is very interesting, Eric. So just to add a little bit of a interesting fact to our conversation, let's see in a traditional hydraulic system, when one gear system rotates, the other gear is driven by the main gear. There is no feedback system here, right? In our drive system, because both motors are servo motors, they have an automatically built-in loop feedback system into it. We will know the position of each teeth precisely in corresponding to the other teeth from the driver number one and the driver number two teeth system, right, or gear system. And then we know the position precisely. By knowing that position precisely, every single time we turn the gear system on a pump, we will know precisely where we are, how much we are off from yesterday, and then how much we have worn the gears from 2 years ago. And when the pump automatically need to call out the headquarters, say, I only have 500 hours left before failure. Now, that data analysis comes with only way that you could have a closed loop, high-speed data circulating through the system and giving the user a phenomenal amount of feedback to analyze reliability, predict in the future. We studied regression in engineering school a little bit. Basically, this pump automatically provides you enough information that you can write up that regression and then create that linear correlation between your uptime and the next maintenance time, and say where we are and how we're going to do that. Imagine how that impact the aerospace business. Imagine how that impact our national defense system, or simply how it impact our day-to-day operation when it comes to driving a tractor. Like when the highway is built, our simple machine, big dozer, has to be up and running because we are running in a very tight schedule, very expensive machines. So it prevents those premature breakage caused by maintenance that it's been lacking.
So you're getting into the preventative maintenance angle, which is which is great and necessary on a lot of these applications. As you said, they can't. They have to work when they need to work, and they can't fail. So you need to know how much life is on. It sounds to me the way you describe that it's really the electric motors that are where the data comes from. I mean, you say you know exactly how those motors are turning, and by extension, then exactly where the two gears inside the gear pump are, if I'm hearing that
Exactly.
right.
So if you
Okay.
know in the CNC machines,
Yeah.
there's a system called probing, right? There's a ruby goes in and touch all the corners, and it defines the position of the machine or home position or coordinate system. Our pump, we build a coordinate system inside of it. Each teeth of the pump is the probe system that probes a corresponding teeth on the other gear system,
Right.
and consequently, it can tell you exactly where we are.
So as you said, that's a different wear and tear proposition because the two gears are synchronized in a way that they
Yes.
wouldn't be if one was driving the other. That's
And
yeah,
here's
right.
the crazy thing. I still get goosebumps when I share this with people. The efficiency, Eric, the efficiency of this pump is linear. You will not lose efficiency in this pump because of the wear in the gear. The gears automatically offset themselves. Without the human intervention, they offset themselves as they go through years and years of operation, as they worn, as the maintenance, not the maintenance, as the gear wear off, or somehow they start having some sort of a leakage internally.
Yeah.
As long as those leakages are in the center of the pump offset itself.
Well, that was the other piece that I wanted to ask about, that controlled internal leakage. If I heard you correctly, it's like normally the plan is to eliminate as much of that internal leakage as possible
Yes.
with your pump design. Here, it's so efficient. It sounds like that you have to actually allow some of it to take place in
We
order
manage
to
that
protect it.
because look,
Yeah.
the internal leaks are bad, but not always. If there is a pump working in Alaska in a minus 50 degrees Celsius, and you want to pump to heat up very quickly to operating temperature of the hydraulic system,
Right.
you want those internal leaks because it causes minor cavitation and heats up the fluid really fast.
Right.
And if we open that pump and allow that working temperature occur within a minute. Uh, so it's very fast. We can use that internal leakage in our advantage. Traditionally known internal leakage, as you said correctly, they are not work in favor of the pump.
Right.
If you have a control over it, you can find a way that you can have those be in your favor.
Yeah, every chart that I've seen, when they talk about internal leakage as a drag on efficiency, right? So
That is
it affects the flow
that is
that you can get out of the pump. So that's why, I guess that's why that really jumped out at me when you talked about that.
That is
Um,
correct. That is correct. We will lock those out. We will not allow internal leaks. I think our alpha is about 5% of internal leak. If that 5% exceeds more than that, the pump automatically trying to close it.
right?
We want to have some internal leakage for due to the lubrication of the bearings and things
Yeah,
like that, but
right.
not it's not substantial enough to affect our
That's fascinating.
efficiency.
Well, that really makes sense then in terms of the higher efficiency or the longer life durability. It sounds like would be a big piece of that as well. So, as a result of that advancement, have you done? I said in the introduction that you have done testing on this for a long
Yes.
time before coming to market. So,
Oh, absolutely. We will have a prototype functioning, ready for live introduction and live testing through some of our partners that we are working with.
uh huh,
We will introduce that in a trade show in FB, and the people can see that firsthand what that drive system look like. We have a pump that has about 6,000 hours on it. We will have that pump at the trade show. The cap is open.
uh huh,
All the data will available for engineers and our partners to look. But if you look at that pump, Eric, after 6,000 hours of pump, there's not even a scratch on it.
yeah. I'm certainly going to stop by and take a look at it
Yes,
while I'm there.
please.
Uh, Through that testing, do you have or can you share any quantifiable improvements that you've seen? I
Yes,
mean, how does it
yes.
compare to the traditional pump situation?
Yes, what we did in a traditional hydraulic system when it comes to gear systems, they are fairly efficient. They are
Hmm.
not they were not the worst in the world, But what we have been able to improve the efficiency of the pump up to 93, between 93 to 98%. And then, but what have really substantially improved, Eric, is the servo response. In a majority of the hydraulic power, as you know, we say hydraulic is powerful but very slow, right?
Right.
But we increase the speed by 15 fold, 15x, not 15%, 15 times. Our hydraulic system respond to upcoming demand much faster than any traditional hydraulic system exists in the world.
Mm-hmm.
That's it. That is where the major improvement is. Yes, efficiency is a given. We know we're going to have improvement in efficiency.
Yeah.
We know our reliability is higher because we have redundancy built into the system, because we can take the pump into a limbo system and have one motor run the other one like a traditional hydraulic system until the service becomes possible, right? And then also we have experimented and we have shown that with our traditional, compared to the traditional hydraulic system, we have about 160 to 170 times, about 165 times more reliability factor built into the system
Yeah.
because of the drive system. And also, one thing that we, most people, most engineers like us, very highly focus on is moving parts. We reduce the moving parts within the system substantially, so there is no wear plates, there is no back pressure, plates in the pump. All that stuff is controlled electronically.
Right.
And then another thing is, if the application allow us, we can get rid of the relief valve completely, which is one of the major efficiency lost in the system, because the relief valve technically controls some of the pressure.
Yeah.
We don't have to do that. Motors, in this case, because of the torque-driven motors, we can determine how much torque we put out, and then that consequently translates to the pressure.
Well,
And then, so there's a lot of things in this system has been improved in a traditional look. Traditional hydraulic system is nothing wrong with it. We love it. We enjoy it every day. We use it. We are coming from a position where say, can we do better?
yeah.
And without discrediting our partners done in Vickers or Rexroth,
Right.
what they have done, moving the technology needle forward. I think what we're bringing in is, hopefully with partnership with these entities, we will be able to take it to a next level.
I was going to ask about, there's a trend in this space that, you know, the unit that you're describing, you'd have one of those for each actuated function on the machine that we're dealing
Yes.
with, instead of having a centralized pump system that goes through a manifold or goes through a series of valves in order to go to different actuators on the machine. It sounds like this is the kind of technology where you'd have one of these for each movement or each motion that the
Yes.
machine needs to do. I'm making that assumption correctly? That's true?
That is absolutely correct,
Yeah.
and that comes from a first-hand experience. I was at the mine at Morenci. I saw one of our large excavators. These are the company that they are millions of dollar worth a machine, and when that excavators go down, several hundred of these trucks that they are within the mine transferring, ore or dirt for the crushers, they go in a stop because of the excavator cannot fill up these trucks.
Yeah.
So I was at the mine one day. I saw the excavator main hydraulic line blow up, and then I asked a simple question: how much does it take, cost to fix that? They said roughly between $80 to $100,000. I said, for just a blow up hydraulic line? They said, well, it's not that. We have to flush the system. We have to clean it up. We have to dedust it. We have to suck everything out
Right.
and clean up the environmental impact. And everything needs to be revisited. They have to go, like a big virus got into human body. You have to go find out
Right.
where it needs to be cleaned up,
Right.
right? Infection. And then, so when I thought about that, and now I think about IES system, what if independently those joints are driven, and if one joint goes down, everything else in the system is still fine.
Yep.
You don't have to change anything. At that joint, simply plug and play. That excavator might be down for days until it get back to commission.
Right.
With IES system, all you have to do is take a few screws off and then unplug the electricity
Yeah.
and plug it back in.
Well, Tom, you've done a great job describing what the product is, as well as a lot of the advantages that it sounds like a huge variety of applications could drive from this. You know, whether it's greater efficiency or preventative maintenance or greater durability, as you're describing. We're coming up on the end of our scheduled time here together. So, what we know we're going to be able to see this technology at the show. What else do you want to leave our listeners with in terms of big takeaways for where you see this technology going?
What I like to leave is we started this movement that hydraulic system can do better, and then I want my colleague, the engineers, anyone who listen to this, look outside the box. You know, we don't have to stick with the principle that is written in our textbook. Say, oh, because of the principle it says a pump need to be a drive and driven, then we have to use a drive and driven pump in order to build up our system.
Mm-hmm.
There are better technologies coming on board every day. Let's be a leader in the world and make the technology, make the hydraulic system, better reliable system, a cleaner system, more efficient system without sacrificing the power. The question is, why do we need to use a massive electric motor to run a robot that we can use a smaller hydraulic system, fluid power to perform the same force and same task, deliver the same force and perform the same task, where a hydraulic motor, where the traditional, electric motor cannot do. I think I want people to think about that. Come see us. Let's discuss this. You're open to any suggestion, any recommendation. This is a brand new technology. We're looking for a good, reliable, and then highly available partners within the industry that we can kind of showcase the technology to them, and hopefully together we can push this to a whole new level.
It's great. Yeah, it's really a good example of the innovation that we're seeing in the industry right now. It's an exciting time to be part of fluid power.
Agree.
And
Agree.
okay. Well, I want to thank you, Tom. That is going to wrap things up for this episode of Fluid Power Forum. Tom.afshari has been my guest. If you'd like to connect with him, he'll be at the IFPE show in March of 2023. If you can't wait, you can contact him by email, and we will put a link to his email address in the show notes for this episode. As always, to learn more about fluid power, your best bet is to attend that IFPE trade show, the International Fluid Power Exposition. And there you can see not just Project Phoenix, but hundreds of other fluid power companies offering the latest fluid power technology advancements and industry expertise. That next show is going to be March of 23. For more information, visit IFPE.com. And remember, if you like our podcast, please follow us on Twitter. We're there at the NFPA. And please keep sharing those interesting and innovative applications of fluid power with that hashtag #OnlyFluidPowerCan. We truly want to hear from our listeners about the kind of topics you'd like to hear addressed on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and I want to remind you to join us next time in the forum.